Well, thank you very much for having me. My name is Mark Sombach. I'm the manager of digital technology at Syncrude. I've been here about a year now. I came from Synovus about a year ago, and over there I was in part of the digital innovation group for many years, which kicked off in 2016. Here at Syncrude, they just started on the digital journey, so my job is to do that digital transformation, take the company from as is to where it should be, catch up with everybody else and surpass them, hopefully. So here I'll go through my presentation and just talk about the data management at Syncrude. So the agenda I'm going to go through is really give you kind of the lay of the land, the current state of where we're at, some issues and problems. Some of these problems are very, very common across our whole industry. And I'll just touch on a few of them that we're running into. Then I want to go through what we want to go for a future state, the direction, the communication technology, the new data sources we're kind of coming into. The architecture, how it's all going to work, and more importantly, our data science, because that's where we get a lot of leverage for the ROIs, etc. And then I'll talk about the time frame, a real rough time, and I'll have a little Q&A at the end, depending how much time we have, because I think there's a break after me, so I don't want to hold anybody up. So our current state is really, this is kind of funny, we do not have a data management governance. We have absent of a managed, oh, something in the way probably, move that over there. Absent of a master data strategy. And what that really causes a problem that we don't have, when we have a data set, we don't have a maintainer identified, we don't have an owner identified, we don't have a steward identified. Those are the things we have to do. We have it for our applications, but we don't have it for the data sets that the applications are accessing. So that's one of the first things I'd be jumping on. And this is not uncommon to the industry. A lot of people have this problem. So for us to move to the digital age, we have to get our data together. There's no way, actually, if I can want to write an AI algorithm or an RPA of some sort of robotic process automation or anything like that, I have to have my data structured and know where it is. So one of the biggest blocks of us moving through and building out those wonderful digital solutions that you heard in the previous presentation, we have to get our data mining in place. One of the biggest things for building these AI, and I've talked to a few people who have built some AI dashboards and some productivity dashboards in the company already. And when I talked to those groups who I met, and they said the biggest problem is trying to find the data and get it all together in one source. That was probably the biggest cost, the biggest deliverable roadblock they ran into. So that's the one thing we got to tackle. And one of the things we have right now too is our IT support that maintains our systems. Our IT system is 100% outsourced. So we don't really have 100% control over the systems we need to get the stuff done. So that just kind of adds to the difficulty and the complexity of getting things around our data all managed. Now the current state, what we did is back in, I think it was spring, it was before I was here, spring of 2019, they had Deloitte come in and do a lay of the land, so to speak. Okay, where are we with the digital journey? What's the issue? And they did touch on our data a little bit, not a whole lot. And they found out roughly 1/3 of our data is unstructured in spreadsheets, which isn't uncommon when you're mostly engineers and you got accountants. Everybody loves working the spreadsheet. The Excel is their best friend. So that's very common. The other one is we have a lot of legacy applications that are old and have their own connected proprietary databases. So if we want to get that data out of the systems, it's very difficult. Any new system we want to go towards, it must have that backdoor, that interface where we can collect the data at the back. We call it an API interface. If I don't know how many people are got an IT background or anything, but that's really important. That's anytime we go to an application, it must have that, so we don't get stuck with the data sets. The remainder of the data, which is probably about 1/3, we do have SAP and we have other systems that do have some structure around them, and we actually use those and trying to leverage those the best we can. Now, what we're doing in 2021, we're changing our IT provider. So we've been with the same provider for about 12, 13 years now, and we're going to be changing some of the IT and some of the structures so we have a little more flexibility. And in 2021, after we change our provider, even doing the transition from the old to the new, it's going to take about 2 to 3 years to complete. Now, the future state is really when we do our IT support for our systems, including the data systems, we're not going to go 100% again. What we're going to do is we're going to break it into commodity and boutique systems. Commodity being your desktop supports, your LAN supports, your cybersecurity support, and the boutique system be stuff like your mining applications, your GMG applications, your engineering applications, and stuff like that. And we'll keep those internally as time. So this is called a bimodal support model. This would be very, very important for us to be successful to go through the digital age. So another thing too, we're going to create an MDM, a master data management. So we are going to look at, get the maintainer, the owner, and the stewards designated to different data sets. But we have to go through all the applications and all the data. And like any other major corporation, there's probably 1,000 applications you have to go through, and they connect to multiple data sources. So I have explained what's the importance of an MDM to a lot of the management. It's the same thing with the maintainer, owner, and steward. Everybody understands the trucks and how they work and how they haul. It's just like if you didn't know where your trucks were, who was driving, or who was the last time somebody put a maintenance, changed the oil on them, you take that away. That's how our data is right now. We don't have that information. So that's why this MDM is so important to our company. Another thing we're doing, a lot of the servers and a lot of the data we have is on our prem servers. So what we want to do is move it to a cloud system. The cloud systems are easy. You don't have to have architects, like infrastructure architects, to maintain all the connectivity and all that stuff. You go to a cloud, it's private or semi-private. We're not too keen on the public because, of course, of cybersecurity issues, but we're going to probably do a private and semi-private for a lot of our systems. We're probably going to classify the different systems. The ones that are really close to our heart, we want to keep those in the private systems. And this is going to happen over that 2 to 3 year transition I mentioned in the previous slide. A future state too, private LTE. Now I know there's some questions earlier about cybersecurity, and this private LTE is basically you take your whole communication infrastructure for your field and you put it inside your firewall. So basically you have your own telecom company within your own company. So this kind of reduces the cybersecurity attack from the outside. And what it basically lowers your telco costs, obviously, because you don't have to pay those data fees or $40 a month for every single IoT device you deploy and stuff like that. It increases your upload and download speeds because you don't have to deal with the VPN anymore. And again, as I mentioned earlier, I touched on cybersecurity for the field. And because we're changing, the whole world is changing. It's just not cybersecurity for your desktop environments and your office environments. We have to have cybersecurity cover all our operations. So this is very serious, and this is one of the ways we can get around it. Another technology, I don't know if people have heard about low-powered WAN. It's really out of Europe. There's one called LoRa. It's one of the standards. And I touched on this a little while ago. North America is just starting to get on the low-powered WAN technology. It's very cost-effective, and it transmits, it's just for data. So when you think about it, you're going to have thousands of different sensors out there for temperature, for measuring fluids, or ultrasonic for thickness of steel. You have a lot of different systems out there. And this is really cost effective in the sense that if you do Wi-Fi systems are the most expensive, of course, they only go for every so many 100 meters or hundreds of meters, depending on what kind you're using. And then of course, cellular's expensive because you have to usually, set up a tower and you got a couple of kilometers range, which is good. But low powered WAN, it costs about $2,000 to set up one gateway, and you get up to 10,000 devices per gateway. This is super cheap, and it's easy. We were already actually setting up for our geotech, managing a bunch of piezometers out in the field. And this, so far we just started, we just kicked it off like a month ago, and so far we're getting success, but I got to let it run through the winter, make sure all the devices I have, work properly. So another one is to have these communication is we need to have the ability to deploy mobile tools. Right now we have dark spots in different areas inside buildings, and we can't deploy this technology. So it's very important that we look at, putting the private LT place. We're actually looking at picocells also, which is a downsized version of a cellular system. It's mainly, if you ever see, picocells are popular inside subways. We're going to try and do inside of our buildings. Like for one of our shops, we don't have any, like the people where we fix these trucks, we don't have any communication whatsoever. So I'm thinking, well, great case for a picocell. And so we're going to be looking at a lot of different technologies around that to make sure we get good coverage right across the whole site. So other one is new data sources. So I just touched on this earlier. When you think about it, as we start deploying these sensors, all different types of sensors, we're going to be in the hundreds of thousands of sensors in our site. This is going to remove the need for people to go out and take a reading and stuff like that. I talked about the geotech, like we had 1,600 piezometers where we have people running out every day taking a reading. Well, there's no reason why we cannot put a little sensor on top of that to take the reading and send it back wirelessly. And so that's one of the experiments we're doing right now. And it's, helps with safety. In the middle of the winter, you don't want a person running out there taking a reading. costs. You don't have to have the person doing it. You may have somebody, changing the batteries every once in a while, but these batteries for these low-powered WAN systems, they run for 3 or 4 years. So it's pretty low that you'll have to send somebody out at all to get these information. Now, another one too is image recognition cameras. So we just did this one where instead of having operators go out and look at things and trial things out, in my previous life too, we did a lot with image recognition cameras for just pond management. We did training of the model for the system. Say, well, when the pond's high or the pond's low, whatever you want to do, we program that into the image recognition camera, and the image recognition camera would tell you, hey, your pond is really high, you better send a crew out to do a pump off or something like that. So that's the kind of stuff we're doing. Here's one we did at Syncrude, is where we had the pipe in the middle was bending, and they had a person going every 3 hours to say, well, has it bent? Because they don't know if they replace it, shut it down, or whatever. So I just had an image recognition camera up there to look at it, and so the other problem is, it was very slight. It was millimeter movement, and the operators could change shifts. So when the operator goes to the next operator says, well, let it move. I don't know. But here with image recognition camera, we can take an image every minute or every hour, whatever you wanted, and basically compare the images, and it can do the analytics behind the scenes, so you don't have to send an operator. It'll tell you when the operator needs to go. So this is just one very basic example that we did, but we're going to be doing a lot more in this area. Another one is drones. I think everybody's worked with drones in the past, and my last company, we had a drone team. We had 5 drones, 2 pilots, and we're probably gonna do the same thing here at Syncrude. And I know some other companies, some of our other peers are actually doing the same thing. Here's one we had kind of an emergency job when our furnaces went down, and there's some work. We had to do some inspections aside before we could start it up again. But we had to clean it out and do all the safety precautions. For the human can get in, you have to put the scaffolding up and all this stuff. Here we just took a drone, which isn't human, threw it up the hole and say, tell me what's wrong. And whatever it was, it found the problem, it was fixable and all that stuff. So we didn't have to take our furnace down for 2 weeks. So the cost of putting the drone and deploying it was thousands of dollars. But I didn't realize till after the fact, it's kind of an emergency job, we saved $30 million. That if we took that furnace down, it would have cost the company $30 million. So stuff like this, and we're getting stories like this right across the board. And I can't keep up with all the good news stories, but it's good. I'm happy. But this is one I just want to talk about, a few of the things we're seeing. So the future state, what does the future state look? I mentioned we're going to the cloud. So we're going to the cloud area, and of course we create these things called data lakes. And these are kind of like information just dumped in there. And the data gets dumped in there is, I shouldn't use dump, but put in there. And it's data that you have verified, you understand it. So you got to trust the data lake. What goes in the data lake, you got to trust it. That's important. And of course, you got a lot of external data like SAP, all these spreadsheets, old proprietary databases. And what we need to do is create this thing called ELT scripts, extract, load, transform. And these are just Python scripts that take the data and dump it in there. And they can run, and this is how you get your trusted data. So you're not really, it's an intermediate source. You don't want to disturb the original source because you want to maintain that quality of data. Then what you do is you put machine learning apps on top of the data lake, and then you create what's called the corpus. The corpus is your knowledge. That's where you want to build your AI off of. And in some cases, you don't have to write an ML script to actually make the data intelligent or get ready for the corpus. You can just go right from the data lake to the corpus and it's ready to go. Then from the corpus, you can actually take and create an AI app, make your bots, your APIs. You heard about this, BI dashboards in Tableau or Power BI or whatever you want to use. And of course, it goes to the dashboard, and that's your decision tool. So this is one thing for internal data systems that you can do using the cloud. And right now, we're using Azure as the database or the cloud infrastructure. And so far, it's going well. But we're not married to any vendor. Like we'll use Google, Amazon, IBM, or whatever. But we just started with Azure because most of my peers have started with the Azure cloud area. So another thing I talked about in the field and communication. So we can have, like I talked about the private LTE, a 4G system. I talked about the low-powered WAN, the LoRa. These are 2 gateways that would come onto the system. And then, of course, you got the image recognition cameras. They would talk here. You got the connected work with all those different mobile devices, and the hundreds of thousands of IoT devices would talk to this. And another one I did talk about is an edge device. Now, the edge devices, if you guys are feeling, they're basically computers in the field. So one of the things I've done in the past too is that the edge devices do all the computations in the field at the point of collection. So this image recognition camera could be running all the time a video. And the video, so you're talking about gigabytes, terabytes of data kind of thing. Then you send it to the cellular network. Now, if you don't have your own private LTE, that's going to be a big bill. Or even if it is your own private LTE, it's going to log down your network because you're sending large bits of data across your network. So what you do, you process the data here. Your AI scripts exist here. So when there's a delta or something you want to see or something programmed through your corpus or AML scripts that sees something, then it'll send it up to an IoT hub, then populates your data lake, and it goes through the process. So these edge devices are really good. And when I worked in my past life, there was one case where we used an image recognition camera, and we shut it down originally because it was costing us $2,000 a month per camera just for the telecom costs. By using an edge device on there, we got the cost down to $70 a month. So it was a big cost savings for getting this information from the field. So this is kind of like a future state. I'm not an artist. There's somebody else doing a better job on this right now as we speak, because this is not the best diagram. But I just want to get the idea across of what the architecture looks like. Now the future, digital twin, again, the future, the first presenter there, he did the same thing. He went through digital twin. Managing the 3D models, that's the biggest thing we have. Again, it comes back to data management. Our previous, or still our way of our data management around 3D models, like everything comes in an AutoCAD or a type of 3D image or something like that. So what we were doing at our company, this is funny, we didn't have a way to store the 3D model. So what they were doing is squish them down to a 2D model and then put them into our system, our data management system, or it was more of just a repository. And so to make the digital twin happen, I did a couple experiments recently with the digital twin with the business, and I had to go back to our original vendors to get our 3D models back. So we have, just around the 3D models is going to be a big deal, because I have to go back for the last 10, 20 years and basically grab all our 3D models and actually put them in a cold storage in the cloud. So the idea, we did this is for one of our I think it was our recycling plant, water plant, and it was really successful. And in fact, we're not even done the experiment, but the feedback we're getting is fantastic. And lots of business units have seen all this, what's going on, and they're saying, okay, we want to do this. And so I got 3 or 4 more experiments that people want to try the digital twin technology out. Now, another previous question I heard is, what's the value of this? And one of the values, and this again from my previous experience, we did a cost benefit analysis on the digital twin models, and we found it's what's called a 15x. So for every dollar you spend on your digital twin, you should get a 10x would be $10 back. This is a 15x. So for every dollar you put into your digital twin model, you'll get $15 back in benefits, and that's from not having people going down the walkdowns anymore because the data is so accurate. It reduced your contingency fees. The design time was a lot faster. And there's a safety component too, also, because you didn't have to have, after it was built, you can actually use the model for doing safety analysis for process safety. And so the costs were fantastic. So for every dollar you put into, you got a $15 benefit in putting a digital twin in place. So we're working on that. The other one is this is kind of the cool stuff, but hey, you got to talk about it. We just bought, earlier this year, we got a whole bunch of HoloLens 2s. It took 6 months to get delivered because they're in such hot demand. The augmented reality versus the virtual reality. Now, not actually versus, you look at both. I've played with both, and I lean toward the augmented. The virtual reality, especially with the person, like we get motion sickness easily, especially as older guys. We get motion sickness. So the augmented reality I found to be much more immersive and was a lot easier to work with. And so right now we're just looking at building some augmented reality from the digital twin models, but we're not there yet. We're just starting that. We just got our devices. We don't have the data massaged yet into a system that we can actually use it properly, but it's coming. I've actually promised my boss I'll give him a demo in April. So I have something to do there. Okay, next one is data science. This is huge. And we're going to work on creating a center of excellence of some sort. We're not too sure what it's going to look like. And one thing we want to do is you just want to have a centralized, all the data science is one area. We're going to focus on a hub and spoke model. We want to have the data scientists embedded in the business, because I find the people that make the best data science algorithms are people that are closest to the data. So if you have somebody in your mining group or your extraction group, you put the data science in those groups, but you still have a central head to help support that person in that area. So as we go forward, we'll be building this out as a hub and spoke model. Now, some experiments we have done in the past, the company's done, is for machine learning, especially for down here on this one here, we used a vendor. We did some predictive maintenance on some froth pumps, very successful. We saved a lot of issues where, where we thought the pump was going to break. We put some parameters in there. It was about 90%. It caught about 90% of the issues, which is pretty good. And when the model wasn't trained 100% was only trained for about a year. If we got to probably 99% if we trained it for a couple more years. So right now on the machine learning, we actually are looking at a lot of different softwares. There's hundreds of different vendors out there with good machine learning systems and software. So we're just kind of doing an evaluation process as we speak right now with a couple. Up here we used an image. This is actually we had a problem. Our plant is quite old. It's 50 years old. We had some of the fireproofing was falling off, was cracking and falling off. We almost had an incident where it fell on somebody, but nothing ever happened. But let's catch it before it does. So we did the laser scans. Everybody's familiar with laser scans. They get about millimeter accuracy out there. So we laser scanned all this one area, one plant area, and we identified one thing. We taught the model to say, well, what has fireproofing? So basically, it was able to, these green squares here are the fireproofing. Like it says, hey, these says fireproofing on it. And then we gave it a hatch pattern. We found there was a particular hatch pattern that showed that it's going to fail or could fail. And those are identified by the blue square. So the AI was basically identified the areas that it possibly have a failure. Then we went in to double check it. Well, really did it find it? And the black squares here, those are the ones that they went in, the human went in and said, yes, this is where it is. So it verified this one, but it did miss down here. So we found out basically all the different models, and we did a AI search on the pattern, and then we did a human just to verify. And it was 75% accurate. It wasn't 100%. So we still have to keep on training the model to make sure that works properly. So the timeline I have here to deploy a lot of this is, first of all, after we start moving to our new IT provider, we get more access to our data systems. We're going to stand up a skeleton data management team. That's probably the most important thing. We actually have it here already, some people on site, but we got some more work to do on that. And then in 2022, we start beginning to building this hub and spoke model, support model. And then 2022, 23, we're going to start developing an OT organization to support all the new IT sensors we're going to be deploying and the gateways. Because right now, a lot of companies don't have, well, you deploy these hundreds of thousands of sensors, you deploy all these gateways and image recognition, but who looks after them? They're new equipment out there. So who does that? And so what we're going to do is we're going to actually stand up another little group, most likely in our OT group, to manage that. So totally net new support model, but the benefits outweigh everything. It's so far we've had some really good successes. So what's the whole idea of all this data management? Just improve the decision cycle, getting that data in, making that decision, getting it done. And I'm not going to, everybody's seen this before, but that's really what the whole idea of doing this whole data management, the whole I thing, is for, really the decision process. And I will stop there. Question and answer, if any questions at all.
Thank you very much, Mark. So we did have one question throughout the presentation, and it was from Glenn. And it was a question about cybersecurity ISAC. Are you members of the mining cybersecurity ISAC? And I suspect that if there's an oil and gas one, that may be part of the question as well.
Yeah, I did send one of, I think we're not members yet. We did I sent one of our team down last December down to Florida for a meeting. So I think we're not members yet, but I think we are interested in being one. And we do belong to a lot of petroleum ones too, like the PTAC ones and all that kind of stuff, but nothing official at this point in time. Again, we're 100% outsourced, so we don't even have our own cybersecurity officer or anything like that internally. That's something will be coming down the way most likely, some cybersecurity agent that we'll have internally to our company.
And the second question is about LTE. How do you get a license? This is from Mark. And are you competing against Rogers for space bandwidth?
When you say get a license, are you talking about spectrum, I'm assuming?
Yep.
Okay. Yeah, so there are some spectrums we have already out there. So I haven't been as close to the project myself, but we do have spectrums available to our company as is already. So we're just going to be using those spectrums. I don't know what the megahertz or gigahertz level is, but we do have some available to our company.
A question for you, Mark, and this is just for me as we wait for some additional questions, but you've really indicated a lot of different use cases that you've applied thus far, and a lot of them have been very successful already. If you were to recommend an entry point for other organizations that are looking to get into the similar sort of digital transformation, was there one project that was really worth recommending?
Oh, that's a good question. There's a lot of good ones. It really depends on you. That's why I kind of started off my presentation on the state of where you're at. Usually I'd start off with more of a data science, if you could, but that's if your data is structured and ready to go. If you don't have that, I'd more focus on the field systems like the IIoT systems or the image recognition for your benefits. And drones are always a good win. That's an easy one. But that's where, so depending on your situation, if you have a good structure and your IT systems are in a good place, then yes, I would go. I'd go with the data science being your first foot forward. If you don't have that structure in place, I would go with a field-based solution. That would be image recognition or IIoT.
And then another question from the group is from Bruce Smith from Enterpro. How do you extend corporate security firewalls at home platforms for work at home? I think you mentioned a little bit already, but maybe you want to reiterate.
So cybersecurity from working from home.
Yeah, rather
yeah, well, we've our companies right now, we're all going back to the office. So again, that would be more of our core IT to help us with that. Like right now, we're basically all our communication is, we do have VPN. We use VPN to get in and out, and that's all we're used for cybersecurity at this point in time. I don't know if hopefully it answers the question, but I'm not sure.
So we should, there's one more. We've got 2 minutes left. So this is
Okay.
from you from I Am Gold. Are you happy with private LTE performance? What's the strength and weakness of this new technology?
Okay, so we're just starting on the private LTE. Some of our some other companies in our area have done some experiments with private LTE. I've done some experiments in the past life. The benefits really really you don't have to use VPN because you remove that cybersecurity level. There's two different levels of private LTE. There's a semi-private LTE where you actually do go through the vendor, and there's a full private LTE where you actually have your own telecom people on site. Our goal, and all the people I've talked to say, go with the full private LTE. That's where your best benefit is, but it's a little bit more effort and work to do that. Again, like going back to the story of if you don't have that spectrum already, then it's going to be difficult to go to the full private LTE. So there's two different levels you can do to it, and I don't know, I think I lost my train of thought. Did I answer that question? It's a little morning, but yeah, the private LTE, I'm expecting good success. Some of the other companies they found it basically gives up to 30 minutes back to everybody in the field because of the VP. Don't have the VPN in and out. That's some of the stories I've heard from the field from other companies. We'll probably experience the same thing and better upload and download times too.
There is one final question. We've got a minute, so
okay.
Go for it. This is from Rene Disse. If it is a greenfields mine to start, would you go for it all at once or have a phased approach to development?
Oh, well, it depends what your budget is. I'd go for it all at once. That's we're going for it all at once, and we're just finding, I went all in forward on everything and just picked off little things as they came along. The only thing I felt bad, and that's why I did this presentation, was really our data management wasn't up to snuff, and that's the only thing holding me back. But I went all in. We're going all in, actually.